Welcome everyone. In this video, let's learn about solving cubic equations. First of all, what are cubic equations? The equations of the form ax cube plus bx square plus cx equals 0 is known as cubic equations. So in this equation, the only condition is I not equal to 0, because if I equal to 0, this equation reduces to quadratic equation. Okay. There are many different shapes for cubic functions. So these are the different shapes as you can see in here. In this particular video, we're going to focus on solving a cubic equation. What is meant by solving a cubic equation? Solving means you're finding the values of x for which this equation is true. Okay, so the left hand side equals the right hand side. For a cubic function or a function of degree 3, there will be 3 solutions. And the solutions can be real or complex or imaginary. The real solutions are the actual x-intercepts for which the function, the graph is cutting the x-axis. Okay, so there can be 1, 2 or 3 real solutions. All of them can be real solutions, 2 of them can be real solutions, and so on. Okay, so for example, in the graph 1, you can see it cuts x-axis only once, so that means it has only one real solution. The other 2 are complex solutions. In some cases, if the turning point is sitting on the x-axis, that means it can have 2 same solutions. Okay, so for example, that's what happens in figure 3. So it is the turning point is sitting at x equals minus 1, so that's the 2 solutions of it. Okay, now how can we find the solutions of a cubic equation? So there are only 2 steps that we need to follow. First, factorize and then use the null factor law. Okay, so for factorizing, we can use many different techniques depending on the type of cubic function. Okay, so one is using the highest common factor. The second one is using the special forms such as a cube minus b cube or a cube plus b cube. And the last one for any general cubic function. Okay, let's do one example from each category. Okay, so the first example is x cube minus 49x equals 0. We're finding the values for x for which this equation is true. Okay, by looking at this, you can see that x is a common factor. We can take the rest into the bracket, so which is x square minus 49 equals 0. Okay, so now this is a linear factor, all done for that factor, but this is a quadratic function which needs further factorization. And looking at this closely, we can see that this is of the form a square minus b square, for which the factors are a plus b times a minus b. So let's employ that one in here. So that's x minus 7 times x plus 7 equals 0. So the factorization is done. Okay, what is the next step? Apply the null factor law. The null factor law is saying if I times b times c equals 0, the possibilities are a can be 0 or b can be 0 or c can be 0. Okay, so that we can apply in here, which then gives x equals 0. First solution is obtained. And the second one, b equals 0, which is x minus 7 equals 0. That gives x equals 7 by rearranging the equation. And the final one, c equals 0, which is x plus 7 equals 0, or rearranging x equals minus 7. So the 3 solutions are x equals 0, 7 and minus 7. Okay, 3 roots for a cubic equation, and in this one these 3 are real solutions, and those 3 are actually cutting the x-axis at 0, 7 and minus 7. Now some of you might be thinking, why can't I apply the algebraic manipulation in here by just rearranging this equation as x cube equals 49x and then cancelling out one of the x from both sides, and then that gives x square equals 49. The problem in here is when you solve this equation, then you get x as root 49, which is plus or minus 7. You get only 2 roots here. So by using algebraic manipulation, you won't be getting all the roots of the function, all the roots of the cubic equation. Rather, 1 or 2 solutions will be missing. Okay, so always follow this factorization and then apply the null factor law. Okay, don't follow this algebraic manipulation because you won't be getting all the solutions in that case. Now let's solve this equation, x cube minus 125 equals 0. So this is of the form a cube minus b cube equals 0. A cube minus b cube can be factorized as a minus b times a square plus ab plus b square. Again, even in here, don't use the algebraic manipulation by saying x cube equals 125 and then x is cube root of 125. In that case, you get only one solution, but you are expecting two more solutions. There could be three solutions for a cubic equation. So don't always follow this algebraic manipulation. Okay, instead follow this factorization. Okay, looking at this equation, x is a and b is 5. So let's do that in here. X cube minus 125 equals x minus 5 times x square plus 5 times x plus 25. That's b square. Okay, so this is a linear factor and this is a quadratic factor. Okay, so now applying null factor law, that's equal to 0. By applying null factor law, x minus 5 equals 0. So that gives x equals 5 as one solution. To get the other solutions, we need to factorize this quadratic function x square. So this gives x square plus 5x plus 25 equals 0. So you need to find the other two factors from this one. To factorize this quadratic function, the easiest method is to find two numbers that multiply to give 25 and adds to give 5. But I can't think of any such numbers in here. So if it's too hard, follow the quadratic formula. Okay, the quadratic formula is saying the solution is x equals minus b plus or minus root b square minus 4ac on 2a. In this one, a, b, c are not to be taken from here. Instead, that's the coefficients in here. So it's a is 1 and b is the coefficient of x, which is 5, and c is 25. So using that one in here, that becomes minus b is minus 5 plus or minus root b square is 25 minus 4ac is minus 100 on 2a is 2. So the solutions are then minus 5 plus or minus root 25 minus 100 is minus 75 on 2. So this explains why I wasn't able to find two numbers that multiplies to give 25 and adds to give 5, because this is a negative number and the discriminant b square minus 4ac is negative, means the solutions are going to be complex. Okay, so the two solutions are minus 5 plus root minus 75 on 2 and minus 5 minus root 75 on 2. So this is one solution, two solution, and the third solution. So it's only one real solution. The other two solutions are complex solutions. Let's now do our final example. X cube minus 4x square minus 11x plus 30 equals 0. So the two methods that we learned so far is not used in here. Instead, we need to follow the general technique. In general technique is find the first factor by using trial and error method, maybe using the factor theorem, and then follow the polynomial division to find the quadratic function and then further factorize the quadratic function. Okay, let me go through this process. So the factor theorem says that for a polynomial px, so this is px, a cubic polynomial, if x minus alpha is a factor, then p of alpha equals 0. Okay, so let's find which alpha gives this function going to 0. So let's start with 1, p of 1. So that is 1 minus 4 minus 11 plus 30, which doesn't give us 0. And now let's use p of minus 1, which is minus 1 minus 4 plus 11 plus 30, and again doesn't add up to 0. And next one is p of 2 is 2 cube is 8 minus 16 and minus 22 plus 30, which is plus 38 minus 38 equals 0. So we found the first factor, first linear factor, which is x minus 2. So x minus 2 is a factor of this cubic function. Okay, this is always our first step, find the first factor using the factor theorem. Okay, then now we're going to divide this polynomial by the first factor which we found. So I'm going to use polynomial division in here, which I'm not going to explain in detail, which you can refer in a previous video. Okay. Now that we performed the polynomial division and we got the quadratic function as the quotient in here, so now we can rewrite this equation as x minus 2 times x square minus 2x minus 15 equals 0. Okay, now it's simple. So we got first linear factor x minus 2. The rest of the linear factors we can find by factorizing this quadratic function. Okay, x minus 2 times, how can we factorize this one? Can we find two numbers that multiply to give minus 15 and then add to get minus 2? Yes, there is. So it's a minus 5 and 3. So the factors are x minus 5 times x plus 3 equals 0. Now using the null factor law, we can say x minus 2 equals 0 or x equals 2, x minus 5 equals 0 or x equals 5, and x plus 3 equals 0 or x equals minus 3. So these are the solutions of x, which are 2, 5 and minus 3. Again, these are real solutions, or these are the x-intercept that cuts the x-axis at these 3 points, 2, 5 and minus 3. So now that we have covered 3 examples, and there are plenty of examples which you can try to master these cubic equation solving.